page. So we're supposed to be doing special right angles today, which are 30, 60, 90, 45, 45, 90. And then we're going to have something called quadrantals. That's when the angle is on an X or Y axis. And you got these 8 problems, and you are going to submit these in Canvas when you're done, a picture of them up in Canvas assignments. So this is right here supposed to be review from back in geometry. You have a 30, 60, 90 triangle, and the side opposite the 30-degree angle up here, this side opposite is called the short leg, because since this is the shortest angle, the shortest leg is opposite of it. The side opposite the 60 is called the long leg, and then the side opposite right angles are always called the hypotenuses. So this would be the hypotenuse here. So the short leg is the most important leg to get because the other 2 sides are based off the short leg. So whatever the short leg is, to get the long leg, you'll take the short leg times radical 3. Now, if you were given the long leg, then you would have to take the long leg and divide by radical 3, because you got to do the opposite to get the short leg. And the hypotenuse is always twice the short leg. So like if this leg up here is 5, let's use a different color. Let's use red. Let's say this side up here is 5. Then you're supposed to take that short leg times radical 3 to get the long leg. So this side would be 5 radical 3, and then you take that short leg times 2 to get the hypotenuse. And likewise, if we were given one of the other sides, let's say we were given long leg, then you would have to take this divided by radical 3. And they're not always real nice like that where they'll reduce. And this side would be 5. And then again, you double that for this one. And if you're given, we'll make up a different size. Let's say I had the hypotenuse given to me. And let's say the hypotenuse was 20. So the short leg, you got to take 20 divided by 2 to get the short leg. And the short leg times radical 3 gives you the long leg. Now, if I go too fast here or you don't get something, let me know. But this is supposed to be a review. Then when you have a 45, 45, 90, this is an isosceles right triangle. Isosceles means 2 angles and 2 legs are the same. These 2 legs are always equal. So if you know one leg, then you know the other leg. They're equal. And then the rule for the hypotenuse is you take one of the legs times radical 2, and that would be the length of the hypotenuse. So that's a quick review of specials from geometry. Then coming over here, we did SOHCAHTOA in geometry as well. And so meant that the sine of an angle equaled the opposite leg over the hypotenuse. And if you notice, the SO comes from the beginning letter of each part. So I highlighted the first letter on each of these with yellow, and the middle letter with blue, and the third letter with green, so you could see where this comes from. So means the sine of an angle is opposite over hypotenuse. The CA is cosine of an angle equals adjacent leg over hypotenuse. And TOA, the tangent of the angle, is opposite leg over adjacent. So we got this thing right here. Now, something else I want you to be aware of that we're going to get to a little later is that when we're talking about points, you know, this is the x-axis and this is the y-axis right here. So this ordered pair would be some x, y right here. And we're going to let the hypotenuse represent an R. That's going to stand for radius, because we're going to get into circles later on. So you're supposed to know that that makes this leg x, because from the origin, you're going out right to get right under that point. So that x would be this x. And then going from here up to the point is going your y value. So this leg would be y. So something we're going to learn today is that we're going to start using ordered pairs to represent opposite adjacent. So what that means is the sine of the angle, I'm going to say theta here because I wrote theta in the picture, is equal to y over r, because this opposite leg is also y and the hypotenuse is also r. So we're going to start using x, y, and r for these. Under the same reasoning, the cosine of the angle is going to be the adjacent, which is the x value of that point, because you're going out x. So that would be x over r. And then the tangent of the angle is going to be opposite over adjacent, which in this case, if we do the lettering from the point out here, that would be y over x. So these things right here all mean the exact same thing. There's no difference, but we need to start learning it in terms of X, Y, and R, because that's what we're going to be using mainly in this class instead of opposite, adjacent, and hypotenuse. Okay, going on. We did these specials on Monday, and I don't really remember how many we did, but I asked you to try to fill out the rest of the sheet. And again, if you look at this, 30, 60, 90, so the short leg's 1, so 1 times radical 3 is the long leg radical 3, and the hypotenuse is 1 times 2 is 2. That's where those numbers come from. And then it says we're supposed to do the angle at 150 degrees. Well, we learned in section 4.1 that we just had a quiz on, and most of you did really well on Friday, that these are the degrees of the angles going around from 0 clockwise. So I hope you can realize that, hey, 150 is over here in this quadrant over here. Okay? So this is 150 degrees over here. That's your theta, 150. Now what we're supposed to do here is use SOHCAHTOA or all that stuff that we had before to get the angle, get what all these trig functions are. So what I want you to know is you always, write this down in your notes, always make your right triangle down to the x-axis, never to the y. So this is our right triangle here. So since this is 150 and 180 is to here, that makes this angle in here 30 degrees, which makes this the 30, 60, 90 we're dealing with up here. So the short leg is 1, the long leg is radical 3, and the hypotenuse is 2. Now the big thing that's a big deal in this is you got to know your signs for what quadrant you're in. So your x and your y over here in the first quadrant are both positive. And we talked about this already too. And over here in the second quadrant, your x is negative and your y is positive. In the third quadrant, everything, the x and y are negative. In the fourth quadrant, x positive, y negative. So we know in this quadrant, which is where 150 is, x is negative. And if you remember, x is the x coordinate here, which makes this negative radical 3. So now we're going to do SOHCAHTOA, or we're going to use x and y and r, depending on what you want to think about. So if I want the sine of 30, that's s, sine is opposite over hypotenuse. This is 1/2. Then cosine is adjacent, which is negative radical 3 over hypotenuse. So this is negative radical 3 over 2. Tangent is opposite over adjacent. So this is 1 over negative radical 3. And then you're supposed to rationalize this. So the shortcut I gave you earlier in the year is you move the radical to the top, and then you take it out of the radical in the bottom. Okay, and then what you do for cosecant is a reciprocal of sine, which means you take whatever the answer was for sine and you just flip it upside down. So this is 2 over 1, which is 2. You take this number and you flip it upside down. So it's negative 2 over radical 3, but we have to rationalize that. So again, we got to take the radical up to the top and you take the 3 out in the bottom. And then you take this one and you flip it upside down. And you should take the original, that way you don't have to rationalize this one that you rationalized a minute ago, and you get negative radical 3. Now again, we talked about this the other day, but alpha is always between 0 and 90. So it is the angle formed with the closest x-axis. So this angle right here, that is your alpha, the angle formed with the closest x-axis. So alpha is 30 degrees in this problem, and they gave us the theta up here was 150. Now on your test, we're going to have a test right before Christmas break, and you're going to be doing this on the test. The test is over sections 4.1 through 4.3, and you're going to be given at least one of those 8 things right there. Please don't miss that part. Please copy down the thing they gave you, like this 150 in this case. Okay, we're going to keep going. I'm going to do the next one. You guys were supposed to try these. I can't remember how many of these you did, but this is 60 degrees, and then 120, and then 240, and then 300. And this is where these angles come from, because you're making 60-degree angles right down here with the x-axis for all these. All these are 60-degree angles right here. So I gave you the way to find the angle. So alpha, this is the alpha, well, they give you alpha, that's the alpha symbol in math right there. So this is the alpha right here. So that's why all these angles, or we're talking all these angles are 60. Don't write all these on this picture because it makes it confusing, but I'm just trying to show you where they come from right now. And so in the first quadrant, which this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, these are the angle measures that if you start here and go around. So in quadrant 1, theta, which is these angles here, theta equals alpha. They're the same in this quadrant. In quadrant 2, theta equals 180 minus alpha. So see, if I take 180 minus 60, that's going from here all the way to 180 and then go take 60 away, go back 60. That's where that 120 comes from right here. And then in quadrant 3, you find theta by taking 180 plus the alpha. And see, if I go here and I go 180 to there and then add 60 more, that's where the 240 comes from. And then in quadrant 4, the rule is you take 360 minus alpha. So we always are dealing with things from the x-axis. So again, 360 is all the way back around to the beginning and then it's back up 60, subtract 60, that's where 300 comes from. And then you can use that same proportion that I gave you back in 4-1 and you can stick these different degrees in here and get the answers. So this one comes out to be pi thirds. This one is 2 pi thirds. This one is 4 pi thirds. And this one is 5 pi thirds. And then we were supposed to make this angle in the 5 pi thirds, which is over here. So again, this is my 60-degree angle, or you might put 5 pi thirds would be this one, or 300. That's your 5 pi thirds going this way, or 300. So that's 60, or you could make it pi thirds, same thing. So since that's 60 and this is 90, this is 30, the side opposite to 30, we let be 1. And then we take the 1 times radical 3 for the long leg, and then we take 1 times 2 for the hypotenuse. And in this quadrant, x, which is the 1, is positive, and y, which is the negative radical 3, or the radical 3 is negative because we're coming down. Remember, this quadrant's positive, negative. So now we do SOHCAHTOA for these 3. And we can actually do these right here. Since they gave me this angle as 5 pi over 3, I should make this pi thirds. I should leave them in radians if they give them to me in radians. Okay? So sine is opposite over hypotenuse. So this is negative radical 3 over 2. Cosine is adjacent over hypotenuse. So this is 1/2. And then tangent is opposite over adjacent. So this is negative radical 3 over 1, which is negative radical 3. And then we flip each one of these upside down. Now, one of the ways that I know that these things here, or what I should say is you should notice that these things are going to repeat all the time. They're going to just keep being the same stuff on 30, 60, 90s. So anyway, I got to flip this one upside down again, and then I rationalize it the same way by flipping or taking my radical to the top and out in the bottom. Flip this one over, just 2. Flip this one over, it's -1 over radical 3. And then I have to rationalize that by moving the radical up to the top and bringing it out on the bottom. We got one more to go, 45, 45, 90s. So if you look, the 2 legs I said will always be equal. And then you take a leg times radical 2 to get the hypotenuse. So there's where that comes from. And these are all 45 degrees. So in the first quadrant, this is 45 degrees. So in other words, we're cutting these right in half. So this is 45. And there's a 45, a 45, and a 45. But if I take 180 minus 45 in quadrant 2, that's 135. 180 plus 45 is 225. And then 360 minus 45 is the 315 here. And then you're supposed to be able to change these into radians like we did in 4-1. So this is what these become in radians. Now, wanting to get this stuff memorized as much as possible because we are going to be dealing with these angles for the rest of trig, and they're a pretty big deal that you know them. So anyway, this one says 5 pi over 4, so that means I am in the third quadrant because that's 225. So we're coming over here. So this is the 45-degree angle. That's your reference angle right there. And I'm going to make this a little shorter because I want it to actually almost look like the two legs are equal. So this is a 45 and this is a 45, and that's a 90, adds up to 180. So my reference angle is that 45 degrees. Now, I should probably do this as pi fourths because they gave this one to me as radians. So it would be better to write this one as pi fourths. Okay, so I'm supposed to know these two legs are equal, and then the hypotenuse is times, radical 2. And then in the third quadrant, this x and this y are both negative, so these are my numbers. So again, I'm going to do SOHCAHTOA with these three. So from this 45-degree angle, we always go from the angle by the origin, opposite over hypotenuse. That's -1 over radical 2. And then you move the radical to the top and take it out in the bottom. This one is adjacent over hypotenuse. So this is exactly the same answer. And then tangent is opposite over adjacent. -1 divided by -1 is positive. Maybe I should write it as -1 over -1. That's +1. And then you flip this one upside down. So when you put the radical 2 over 1, it's just radical 2 and keep the sign with it. This is negative radical 2 as well. And this is 1. When you flip those upside down, there's still 1. And the last kind of angles we need to worry about are quadrantals. That means they are on the x-axis. So see, 0 degrees here is over here, and your x is 1, your y is 0, and your r is 1. This is where your x and your y over r and all that stuff come in to help you with these. So sine is y over r. So this is 0 over 1, which is 0. Cosine is adjacent, or x over 1, which is 1 over 1, which is 1. And then tangent is y over x, and 0 over 1 is 0. Now I'm going to go ahead and do the reciprocals of these. And you probably ought to do these on your own. So when you flip these upside down, if you flip 0 upside down, 1 over 0, you cannot divide by 0. So this is undefined. So if you get a 0, the reciprocal is undefined. If you get an undefined, the reciprocal is 0. Reciprocal of 1 is 1, and this one is undefined. And alpha is 0 degrees. 90 degrees is this angle right here. So now your ordered pair is the x is 0, the y is 1, and the r is 1. So y over r, 1 over 1 gives you the sine is 1. Maybe I should put 1 over 1 first. Cosine is adjacent, or x over r, which is 0 over 1, which is 0. Tangent is y over x, which is undefined. Now alpha, again, is this angle from either x-axis. It's 90 degrees here. Okay, so it's 90 degrees. And then you flip these upside down, so cosecant is going to be 1. Secant is going to be undefined. And then cotangent is going to be 0, because 0 is a reciprocal of undefined. You flip this upside down. So we'll see if you guys can finish these last two. All right, I'm going to come over here now. And this is the homework you're dealing with for today. Now we're doing 4 to 32 by 4s. So again, you need to know that the sine theta goes with the y value, okay? The cosine theta goes with the x value, and the tangent of, the tangent of theta is y over x, okay? Now these are over r, but you need to know that r is always positive. R can never be negative. Okay, so cosecant is the reciprocal, come on, pen. Cosecant is the reciprocal of y. So this is actually y over r, this is r over y. And then this is over r, and secant therefore is r over x, and cotangent is x over y. So kind of a big deal if you know this. So I'm going to do this number one. It says sine of theta is greater than 0. So that means y is greater than 0, and cosine goes with x, and x is less than 0. So I want to know what quadrant this is true in. So where's y greater than 0 and x less than 0? Well, if you think about this, about the quadrants, again, these are the signs of the x and the y in different quadrants, 1 through 4. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We want to know where's x negative and y positive. Well, x is negative in these two, and y is positive up here, so this is quadrant 2. Coming over to this one, this says y is less than 0 because y goes with sine. X is greater than 0 because cosine and x go together. So I want to know where's x positive and y negative. Well, x positive, y negative is quadrant 4. You get any idea where these are coming from? Let's do secant and cotangent. Now this one's a trickier one. So secant is r over x. So what that means is secant goes with x. Okay, so number 5, secant goes with x. So that means x is less than 0, and cotangent is x over y. So x over y, it says, is going to be greater than 0. It's going to be a positive. Well, this x and this x have to be the same. So x less than 0 means that x has to be a negative. So this is a negative over something that's got to be greater than 0. So I hope you know that if you take a negative divided by what gives you a positive number. So a negative divided by a negative gives you a positive, which means y is also negative. So x is negative and y is negative. So since both those are negative, that's quadrant 3 for this one. Okay, so let's do one of these over here. Let's do, let's do number 9. Let's not do 9. Let's do 13. So 13 says cotangent and secant have opposite signs. Cotangent and secant have opposite signs. So I'm going to do it like this. I'm going to put them beside each other. And then I'm going to do quadrant 1. And we want these to be opposite signs, it says, right? This is number, 13. Cotangent, secant. Yeah, opposite signs. So in the first quadrant, cotangent is x over y. So if I do x over y, positive over positive, cotangent is positive. Secant, remember secant is the x value. So in quadrant 1, secant is the x value, which is positive. So in quadrant 1, they're the same sign, so this doesn't work. Let's check quadrant 2. If I go to quadrant 2 and I do x divided by y, that's a negative. A negative over a positive is a negative. In quadrant 2, secant again is with the x value. It's got to do with x, so in quadrant 2, it's negative. So they are the same sign in quadrant 2. In quadrant 3, cotangent is x over y. Negative divided by a negative is a positive. In quadrant 3, the x value is negative. Secant goes with x. So there's one quadrant where their signs are opposite. And in the fourth quadrant, if I do x over y, positive over negative, so positive divided by negative in the fourth quadrant is negative, and secant is the x, which is positive. It is fourth quadrant as well. So the answer to 13 is both the third and the fourth quadrant. They both work. Okay, then it says on a separate sheet of paper. Now you're going to take pictures of this stuff and send it to me, right? You're going to work all these out on different pieces of paper. I'm going to do, we already did 15 way back in the answer sheet, but let's do 19. We did 225. Let's do radian. Well, let's do a negative one. Let's do 27. So 27, oops, wrong color. 27 says, I'm going to go back here and show you this. Oops, don't want that. says that we are given on a set, draw each angle in standard position, find all 6 trig functions, be sure to mark them all. Okay, all of these angles are theta. These angles all given to you are theta. So when I come over here to this, what this means is theta equals negative 30 degrees. So I'm going to draw negative 30 degrees like we did on the 4-1 quiz. So I have to start here, and I have to come down this way, negative 30 degrees. So this is negative 30 degrees. Now alpha has to be a positive angle. Remember, alpha must be between 0 and 90. Okay, so if you put a negative for alpha, it's going to be wrong. So the question is, how many degrees is this from here to here? Well, we don't have to go in a direction. We can just say it's positive 30, and that is going to be our reference angle, alpha. So we have a 30. Now, I would use the reference angle here instead of the theta. We're going to use that reference angle of 30. That's 60. So the short leg is 1, the long leg is radical 3, and the hypotenuse is 2. Now we're in quadrant 4. So in quadrant 4, x is positive, y is negative. So here's my x is that 3, and my y is this 1. So I got to make that 1 negative. Now we are supposed to give the 6 trig functions like we did on the very beginning of those note sheets. Now, some people have a hard time remembering what the reciprocals are. So I'm going to tell you how I memorize it. If I deal with sine, cosine, and tangent are the big 3 that we need to know for sure. So the way I remember these first 2 reciprocals is sine starts with S, so its reciprocal starts with a C. So this S tells me its reciprocal is a C, and since cosine starts with a C, its reciprocal starts with an S. So they're opposite signs of what you start with. And tangent and cotangent always are reciprocals, so they both have tangent in them. Okay, so sine is opposite, negative 1 over hypotenuse. So this is negative 1 over 2. Cosine is adjacent over hypotenuse, so this is radical 3 over 2. Tangent is opposite over adjacent, which is negative 1 over radical 3. And then I rationalize it by moving the radical to the top with a negative 1 and taking the 3 out in the bottom. Cosecant, I flip this upside down, so that's negative 2. Secant is 2 over radical 3, but I need to move the radical up with the 2 and take it out in the bottom. And cotangent, I want to flip this one upside down, so that's negative radical 3. And again, alpha is 30, and theta is going to be negative 30. That's the one they give you, just like on those example sheets. So this thing right here is what you're doing on all of these problems down here. And you are doing, for today, you're doing 16, well, you're doing all these. You're doing 4, 8, 12, 16, 20, 24, 28, and 32. That's what your homework is today, is to do those. So those first 3, 4, 8, and 12 are just asking you what quadrant are you in. And then 16 through 32, those are asking you to do those 6 trig functions like I just did. I'm going to make that yellow sheet disappear here, so hold on a second. Now that's a lot of stuff, and this stuff is not easy. So you got to ask me some questions if you have any yet. Maybe you're not going to have any today. Maybe it's going to be tomorrow. Because I know that I make this look easy, but it's not. So these 16 through 32 should all look like this. Oops. They should all look like this when you're done. You should draw a picture like this, and you should put all this stuff down. Every one of those needs a picture of an XY axis and a right triangle drawn. Does anybody think they got any questions on that? Because this stuff's pretty hard. Okay, then I'm going to sign off, and I will see all of you tomorrow, and make sure you come in tomorrow with questions. We're going to be doing this same stuff again tomorrow. Actually, we're going to do some extra stuff tomorrow too. So if you get any questions, Make sure you have them ready to go tomorrow. Write them down so that you can ask all the questions you want to ask. Okay? All right. Well, I will see you guys tomorrow. Have a great day. And good luck on this homework because it's pretty hard.